Okay? So far we've had 2 equations, 2 unknowns, pretty straightforward. Now let's take a look at 3 equations, 3 unknowns. And our first example we have is x minus 2y plus 3z equals 9. We have y plus 3z equals 5. And then finally, z equals 2. So we're going to use back substitution on this problem right here. So here I have 3 equations and 3 unknowns. That means we're going to have 1 unique answer, and we'll talk about that more in detail. But again, we know that z equals 2, so if we go backwards, I'm going to plug the z equals 2 into that equation, solve for y, and we get y plus 3 parentheses 2 equals 5. We get 6. So y plus 6 equals 5 minus the 6 minus the 6. Therefore, y equals negative 1. Okay, again, substituting back one more time, I'm going to now substitute into this equation because we know what y is equal to and what z is equal to. And now we want to find what x is equal to. Okay, so we're going to substitute it in, solving for x. 2 times negative 1 plus 3 is 2. 3 times 2 equals 9. Okay? Again, I can't stress enough, I use the parentheses to show you that I am substituting in. Not only that, if you use your calculator, it helps you out. Make sure you don't make a mistake. So this is what we're doing here. We get negative 2 times negative 1 gives us positive 2. So we get x plus 2. 3 times 2 is 6 equals 9. We get x plus 8 equals 9 minus the 8 minus the 8. Therefore, x is equal to 1. Okay, and then if we list our answers, here we go. There are our, okay, so there is our 3 solutions, 3 equations, 3 unknowns. We have 1 unique solution. That's where they would cross if we actually graph these 3 lines, the 3 variables right here. Okay, so let's take a look at we're going to combine methods right now. We're going to combine row elimination with this back substitution idea, and let's see what we get here. Okay, that problem pretty straightforward. Let's look at question number 2. So we use row elimination. We're going to now combine methods together, and that's what most times you have to do is combine methods. There's no one straight way to do it. Okay, we're going to either substitute row elimination. Sometimes it's row elimination with a little substitution. Back substitution, row elimination. We finagle problems. We try to figure out how to get the best answer. So we'll take a look at something like that. That's question number 2. We got x minus 2y plus 3z equals 9, negative x plus 3y equals negative 4, and we have 2x plus 2x minus 5y plus 5z equals 17. Okay, so we look at this problem, and there's no one variable by itself isolated. So what we have to do is do a little elimination ourselves to get something eliminated. And we'll start with 1 and 2. So I'm going to add 1 and 2. If I add 1 and 2, it eliminates our x. So we'll call that 1, 2, and 3. It's a good idea to keep track of our 3 equations. So I'm going to do 1 plus 2. So that gives us x minus 2y plus 3z equals 9. And negative x plus 3y equals negative 4. I'm adding 1 and 2. Bye-bye. We get positive y plus 3z equals 5. Okay? So there's one equation we're going to work with in a second. Now I'm going to take negative 2,